Hello everyone and welcome back to the Jamaican Geologist YouTube channel. So this is episode 2 of the Geology Foundation Series, and this is your go-to introduction to the world of geology, where we break down complex concepts in a fun and engaging way. So today we are diving into the many branches of geology because it isn't just about rocks. In fact, it's an incredibly diverse and interdisciplinary science that touches nearly every aspect of Earth and the planetary processes. So now I must say that this list I'm about to share isn't exhaustive. There are many branches out there, so if any geoscientists are watching and notice something missing, please feel free to add it in the comments. I've put together about 18 categories, so sit tight. It's going to be a long one, but I promise it'll be worth it. So let's start with petrology, often thought of as the heart of geology. So while many people equate geology with the study of rocks, the specific discipline focused on rocks is called petrology. And the term comes from petro, meaning rock, and logi, meaning study of. So petrology examines the origin, composition, and structure of rocks. And petrologists might study a thin section of a rock under a microscope to understand how it formed deep within the Earth's crust. And this branch of geology plays a vital role in interpreting Earth's history, guiding mineral and oil exploration, and helping to mitigate disaster risks. So, closely related to petrology is mineralogy, and this is the study of minerals, their properties, structures, and classifications. In fact, I recently featured an interview here on the channel with Dr. Dexter Perkins. You can check it out. But Dr. Dexter Perkins is the author of the textbook Mineralogy, which I used during my undergraduate studies. And the term mineralogy combines mineral and logi. And mineralogists help identify critical minerals like rare earth elements, which are vital for electronics and other technologies. And the field is crucial in mining, material science, and even environmental cleanup efforts. So next up is structural geology, which focuses on rock formations and the forces that deform them. So structural geologists, they study features like folds, faults, and fractures. For example, they may map faults to assess earthquake risks. Um, and this knowledge is essential, especially in earthquake prone regions or for large scale construction planning. So then we have stratigraphy, which looks at rock layers and, well, their layering. The name comes from strata, which means layer, and graphy, which means writing or description. And stratigraphers might analyze the interbedded sandstone and shales of the Richmond Formation in Jamaica. This branch is especially useful in oil exploration and in dating rocks through their relative position in the geological record. So, closely tied to stratigraphy is sedimentology, which studies how sediments like sand, silt, clay, and gravel are produced, transported, deposited and turned into sedimentary rocks. And the word comes from sediment, which means settled matter. And a sedimentologist might examine grain size trends in a river delta to understand how current strength shifted after a flood. This field helps reveal past environments and climates and is key in identifying groundwater and petroleum reservoirs. I should note that sedimentology and stratigraphy are they often overlap, and you'll see this connection explored further in future videos. Now let's talk about volcanology. Very exciting, it needs no introduction. It's the study of volcanoes, magma, and related eruptive processes, not just on Earth, but also on other planets. And volcanologists monitor gas emissions, for instance, to forecast potential eruptions. And this field is critical for protecting communities living near volcanoes and improving early warning systems and even advancing geothermal energy development. So, a very exciting and critical field. So, seismology is another vital branch, and it investigates earthquakes and the seismic waves that travel through the earth. And in Jamaica, we have an earthquake unit that frequently shares updates on seismic activity. And you may have seen their posts on social media following earthquakes in the island. And we'll dive deeper into earthquakes in Jamaica in future episodes. But seismology supports early warning systems, it shapes building codes, and offers insights into the structure of Earth's interior. So, hydrogeology is the study of groundwater, how it moves through the soils and rocks, and its quality. And in Jamaica, the Water Resources Authority is the main agency overseeing groundwater management. And I actually created a video for World Water Day 2025 that highlighted their work. And understanding groundwater is essential for securing drinking water, predicting contaminant plumes, and planning for drought resilience. Then we have paleontology. Well, the spelling might vary based on which part of the world you're from, but paleontology is a study of prehistoric life through fossils. And while many people think of dinosaurs, fossils are so much more. In Jamaican limestone, for example, we find abundant fossil life, including foraminifera, which we casually call forams, gastropods, ostracods, bivalves, rudists, corals, and even ancient mammals and birds. We'll explore these fascinating fossils in an upcoming video, but paleontology provides vital clues about evolution, past climates, and extinction events. So, geophysics uh, applies physical principles such as gravity, magnetism, heat, and electricity to probe the Earth's structure. For example, magnetic surveys are used to locate ore bodies buried beneath tropical soils like laterite. And in Jamaica, exploration companies frequently use geophysical methods in their prospecting. And this non invasive approach is essential for mineral exploration, geothermal development, and hazard assessment. And it's also closely related to seismology, as both use waves to understand subsurface features. So another important field is geochemistry, which studies the chemical composition of earth materials and the chemical processes that shape geological phenomena. Geochemists, they might analyze strontium and oxygen isotopes in Arctic ice, and this field helps us determine the absolute age of the rocks and guide mineral exploration and monitor environmental contamination. So it is a wide field. There is aqueous geochemistry and there is isotope geochemistry. And I'll go into detail in future videos. So environmental geology now is all about applying geological knowledge to solve environmental problems. So for instance, it plays a role in investigating soil and groundwater contamination, which is crucial for pollution cleanup and land use planning. So one area I'm personally familiar with is economic geology, which I worked in for much of my career. I focused primarily on industrial minerals in Jamaica, like limestone, gypsum, clays, sand, and gravel. And these are also known as aggregate. Um, but I've also been exposed to metallic minerals like copper. And economic geology determines whether mineral resources are economically viable for extraction, estimating their quantity, their value, and the potential lifespan of a mine. So it's a key driver in mining and in the global economy. So engineering geology now combines the geological knowledge with civil engineering. It is used to assess whether a construction site is suitable and safe. For instance, before building a highway, an engineering geologist would evaluate the slope to prevent landslides and collapses. And this branch is key in preventing costly engineering failures. So, although it may seem far removed from our tropical region, glaciology, which is the study of glaciers and ice sheets, is still very, very relevant. So, while Jamaica doesn't have any glaciers, understanding their behavior helps us predict sea level rise and global climate change, both of which have very real effects on Caribbean nations. So glaciologists, they study polar melting, which is vital for understanding the future of our coastal communities. Geochronology now focuses on determining the age of rocks, fossils, and sediment. The term comes from geo, which means earth, chrono, which means time, and logi, which means to study. So it's a combination of three things. Techniques like radiometric dating allow us to determine the age of meteorites and build an accurate timeline of Earth's history. So finally, we come to planetary geology, which expands the study of geology beyond Earth to other celestial bodies such as the moon or Mars. And by analyzing Martian soil or the lunar surface, planetary geologists help us better understand the solar system and lay the groundwork for future space exploration. And that wraps it up. Our journey through the many fascinating branches of geology. If you made it this far, thank you for sticking with me. And remember, geology is more than just the study of rocks. It's a powerful lens through which we can understand our planet, its resources, and even its future. So be sure to like, subscribe, and drop a comment if you have any questions or insights to add. So until next time, keep exploring, and remember the Earth has many stories to tell. See you next time.